In the previous video, we saw how to read the data set stored in different sources, like stored as a CSV file or a text file, or if it is stored in a database. So now here in this video, we are going to see how to do the exploratory data analysis. So we are still going to use the same data set. So let's pick up this data frame which we read from the CSV file. So the first one is we are going to use the info function. So this provides us details about the data type of each and every single attribute that is available in our data set. So here we can see that suburb and address are stored as an object, room is stored as an integer, price is stored as an float. We can also see that the date is stored as an object. So if we want to do any filtering any sorting based on date, so then maybe it would be better to store the date column as an date time or a date data type. So if it is stored as an object, maybe if we want to sort, it might not be proper. So this gives us a better understanding about the data types of our attributes. So now the next function is describe. So this helps us in giving a view of all the numeric columns. So we can get an understanding about the distribution of each and every single attribute. This also provides some inputs on the outliers. So we can see that the average number of rooms per property is 3, but there are some properties with up to 16 rooms. So even though the 75th percentile is still 4, so this seems to be like an outlier. So the price is also like skewed. There are some properties which are very expensive, and each and every single attribute like distance, even though the average is 11 kilometers, we can see there are some properties which is about 48 kilometers. So this gives an understanding about our data set and its distribution. So now, having a very good understanding about our data set, about the data type as well as the distribution of numeric columns, so now next what we can do is we can check if there is any missing value. So we can use something like isNA in order to get the count of the missing values for each and every single attribute. By using the sum function, what we can do is we can get the summation of the missing values for each and every single attribute. So here we can see that the price attribute has about 7,610 records with a missing value. So this gives us a count, but this still doesn't provide us the magnitude of the missing data with respect to the whole data set. So what we can do is we can just simply divide this by the length of the data frame and multiply that by 100 in order to get the percentage. So now what we get is we know that the price attribute is missing in about 21% of the cases. We can see that the building area as well as year built are the most poorest quality attributes, which is missing about 60 and 55% of cases. So what this tells us is if we are going to use this attribute in our model for prediction, so the model is going to perform very badly, because like these attributes has a lot of missing data, so it would be just a noise for our model. So this tells us that these attributes doesn't need much analysis, and maybe it's better to omit those attributes from the analysis as well as from the model. So here, so the missing values. So we have seen like how to identify the missing values. So next one is if we want to replace the missing values with another value, like how we can do it. So let's say we just copy this into a new data frame, and let's pick up this new data frame here, and let's just pick up one attribute, let's say price. So we want to replace the price. So what we will do is we want to replace the price where only for the records where it is not available. So what we are going to do is we are going to fill the non-available data with let's say with the mean of the same column. Okay, so now what this is going to do is, this is going to replace all the missing values with the mean of that particular column. So now what we are going to do is, we are going to just copy the same command in order to get the view of the missing data, but replace the data frame with a new data frame. So now let's execute this one. So now we can see that there is none that is missing for price. So what it has done is, this particular function has replaced all the null values with the mean of the column. Hence here we don't see any missing values. So this is just one of the treatment method. So depending upon the situation, we can follow an ideal method to handle the missing values. So what we can do is, instead of just replacing it by the mean of the whole column, maybe what we can do is, we can get the mean based on the postcode, or based on the suburb, or based on any other parameter, and replace it, so that it becomes it becomes slightly closer to the actual value. Or we can even still go further and replace based on multiple attributes, based on the postcode, based on number of rooms, or based on the size of the property, number of bedrooms, and so on. So okay, so now having a good understanding about our data set and the distribution of our data, and knowing about the number of missing values, and maybe replacing them with the most suitable values. So now let's move on to the univariate analysis. So we call this univariate analysis because we are going to do the analysis for one attribute at a particular time. So let's say we want to do the analysis for the price. So first, so here we want to do some plots. So what we do is, we import the matplot library, and we also import the Seaborn library. So we are going to use these two libraries for plotting. And what I'm going to do is, I'm going to just define the size of our chart, so it doesn't become too small or too big. So based on trial and error, we can come up with the ideal size for the chart. And now coming to the actual distribution plot. So here in the distribution plot, let's say we are going to plot just for price attribute. So now here we just want to plot an histogram, hence we will set the KDE as false, and let's just use some color to the chart. So we use the edge color parameter, and maybe set it to gray. Okay, so now we are going to plot the attribute price. Okay, so now what we can see here is, we see here that the chart is very skewed. So we can see a lot of data on this side towards the left, whereas as it goes to the right, there isn't any data. So what we are going to do here is, I'm just going to use the dot location attribute and filter our data set only for the properties which has a value less than 1 million. Okay, so now this should ideally work. So now let's just re-execute it. Okay, so now we can see, considering only the properties which are less than 1 million, we can see the distribution is pretty much close to normal. We can see it peaks here about 600k to 700k and drops as it goes further. So this gives us an understanding about how the data is distributed for one single attribute. So hence it is called as an univariate analysis. So now let's move on to the multivariate analysis. So let's maybe check out the bivariate analysis, where we take two attributes at a time. So here in this case, maybe let's pick up price along with the date in order to see the trend of this particular attribute. So I am going to copy a piece of code here. Okay, so here we are going to use the matplot library, same library. What we are doing here is we are converting the date parameter into date time data type, so that we can do the sorting based on date. And what we are doing here is we are going to filter only certain house types. So instead of having huge amount of data, we are going to filter only the properties which are house. We are going to remove all the townhouses and other properties, and we are going to filter only houses which has rooms less than or equal to 4. So here we are calculating the variance, and second, here we are calculating the count, like of so this filtered type of properties, and we are also calculating the mean. So now here we are going to plot the mean along with the variance in order to see the trend over the time. So let's just execute it. Okay, so now we can clearly see that there is the mean, and this captures the variance for the date from 2016 to up to 2018 October. So here what we can do is we can maybe add in the filter on price. So we can add one more condition here to see how the data is changing over time for this type of properties. Okay, so now let's just re-execute it. So now we can see that the variance has reduced a lot, because there has been some outliers. We have removed the outliers by considering only the properties which are less than 1 million, and the trend now is like pretty much steady. There hasn't been much of a change from 2016. We can see that it's slightly moving down. So this analysis helps us in better understanding the data. So we can take two attributes at a time and then see how they are distributed. So let's say maybe we want to stick with tabular data, and we want to see how maybe more than two attributes are behaving when compared across each other. So what we can do is we can simply use something called as a group by, and we can pick up the attributes that we want to compare. So let's say I want to compare the region name along with the type of property, and I want that to be compared with the price. So now while doing the group by, we need to mention the aggregation. So what we can do is we can, here in this case, we can mention it as mean. So the price will be averaged based on the region name and the type. So what I want to do is I want to save this into another data frame. So let's say group by df, and let's just print this particular data frame. Okay, so now what we can see is we can see the data has been grouped by based on the region name. So let's say if we take Eastern Metropolitan, so we have the various house property types like house, townhouse, and unit, and we have the average price for each type of property. So this also helps us in understanding about the the different parameters and helps us in understanding about how the data is distributed. So from here what we can see is in general maybe the house properties are slightly expensive, and we can see the southern metropolitan, and that southern metropolitan especially seems to be the costliest suburbs. So it has properties whose average values are quite high. So this could be maybe because of few outliers that are present in this particular location, or maybe the data set as such is behaving in such a way. So this helps us in understanding about how multiple attributes when brought together behave and related to each other. Let's also quickly view about the regression between different attributes. So we are going to use the LM plot here. So let me copy a piece of code that can be used to plot the regression between multiple attributes. Okay, so now here what we are doing is we are going to compare the distance and price for the properties with different sets of room. So let me execute it. So this is a very interesting plot which helps us in understanding the relationship between different attributes and how it is trending. So here we can see the price on this axis, y-axis, as well as the distance on the x-axis. Each of these colors represents the categories. These categories like properties with 1, 2, 3 or 4 rooms. So we can see there is a steep decline for properties with 1 rooms. With the increase in the distance, the price of those properties drop significantly. Whereas for properties with 2 rooms, the decline is not so much. It's slightly more stable. And whereas in case of properties with the 3 rooms, like it seems to be more or less a parallel line to the blue one. And the lighter color also tells us about the distribution. So the broader the width is, it means that it can range from here to here. So there is this, for these properties with 1 rooms, it has a huge range. So this is another examples which helps us in understanding the relationship between like multiple attributes. Okay, so now let's go for some workout examples that maybe you can try. So some of the questions that you can try is you can check out what's the average price of properties by postcode, the number of properties by region, and average property prices by suburb, and what's the most popular suburb. So either this can be based on the price of the property, or the number of properties are available in each of the suburbs, or the maximum number of properties that are sold. So you can consider like whatever like maybe ideal, depending upon what you see as the best for this particular question. And the last one is what is the relationship between the number of rooms and property prices. So these are some of the sample exercises that maybe you can try out using the techniques that we have discussed so far. So that's it about the exploration analysis. So this is what we call it as the EDA, so exploratory data analysis. So this is the most important part of the data science project. So this helps us in understanding the data set better. So the model that we build can be optimized depending upon the data set. So let's check out about building the predictive model in the next video, and that's it for now. Thank you.